all the pipe materials, the cross sections of the or the shapes of the sewers, and we had done some numericals regarding calculation of dry weather flow, wet weather flow for combined sewers, separate sewers, and partially separate sewers. So I hope all of you have become very clear with what is the expression that can be used to calculate the quantity of stormwater flow, how the coefficient or impermeability coefficient or coefficient of imperviousness can be calculated based on the type of cover that particular area is having. So today we need to look at how the sewers are being laid. So we have seen that there are various types of sewers. The main sewer, which will be carrying the maximum amount of wastewater. The branch sewers, which will be carrying the wastewater from different areas towards the main sewer, and the lateral sewers, which are probably the sewers in a particular lanes or roads within the layout. Now, whenever laying of sewers are done, they always start from the lower end. That is, we call as many times we have come across the term outfall sewer. That is the place where the sewer goes into the discharge portion or where treatment and things like that is happening. So from the lower end to the higher end is how the sewers are being laid. Now, you all have learned how center line marking is being done, especially when you have gone for internship and things like that. Building center line marking, you would be seeing how they mark the center line. So now you have to imagine that we need to put the sewer under the ground, okay, at a particular place. Sometimes it will be on the side of the road. There are cases where the center of the road is also being put for large sewers. We may have it at the center of the road. So wherever the road or by the side of the road, wherever we need to do it, the center line is marked with respect to how much of trench excavation need to be done. So if we are talking about a main sewer or a branch sewer or a lateral sewer, depending on the size or diameter of the sewer that is going to be laid, that distance from the center line, plus you need extra room, right, for putting these things in, so that will have to be done. So center line marking is again an important step in the process of laying of the sewers. So they will take the plan of the area where this particular sewer line has to be laid, and based on decisions as to whether it is on the left side of the road or the right side, they will decide to have the sewer line laid or at the center. All these sewer center lines will be marked in the plan. And then we have an important appurtenance, which is called by the term manhole. Manholes are very large chambers that are connecting different sewer lines. And we will come to the next portion where we will study where the manhole will be located and things like that. But the position of manholes will be marked, and the center line will be connecting all these positions of manholes, so that in your plan you have a correct idea as to where these positions are. Now you need to put that on the ground. So once this plan has been approved, we have to start the work. So the center line of the trench, wherever we have to start, you would have seen the common way in which they put pegs, okay, and they will put a string and then mark that in a line on the ground using the white chalk powder or whatever it is. The same way they do it here. The centerline pegs are first driven. So when suppose we are marking the center line for a building and all, if our ground is probably relatively straight, right? But here we are talking about in the case of a road system. So sometimes the road will have vertical curves. It may have horizontal curves and things like that. And so based on whether the road is straight, whether there are curves, you decide what spacing these pegs should be put at. So if you are having a relatively straight ground, you can keep it further apart. So they say 15 meters. If you have a place where the road is taking a curve, then the pipeline also has to follow the road. You can't go in another way. So you keep the pegs at a closer place. Now, there are two very important components. Okay, they are called as site rails and boning rod system. So what a site rail means is a horizontal beam of wood which is across the trench that is being dug. So on two sides, they will put down the vertical supports, and you will have a rail or a piece of wooden member which is across the width of the trench that you are digging. And a boning rod system, they call it as a traveler also, is some instrument which is very similar to that of your T-square. You have seen the T-square that people use to do drafting, right? It is a T-shaped structure. So this has got a bottom portion which has got a shoe-like part where it can be dipped into the trench, and then you have a vertical portion where it comes out from the ground so that you can measure the depth of the cutting that you are doing. So site rail and boning rod system is the most accepted method for laying of drains for getting accurate gradients. So why gradients are important? Now, when you are laying the sewer line, if you lay it as the road goes, sometimes the water may not flow. So you need to have the gradient of the pipeline in such a way that the water or the wastewater flows towards the downward direction where your treatment plant, or it is able to flow by gravity towards the treatment plant. So you have an entire layout or an entire city with different connections. Wherever the treatment plant is, all the wastewater has to be carried there. So the best way from, let us think about a layout now. So from a layout, all the wastewater coming from the lateral drain pipes lateral sewers that you are laying should be able to reach a branch sewer. Let us talk only about that part now. So that means all the water from each individual building will enter into a lateral pipe, and there will be so many such lateral pipes which are getting connected, and all these pipes should be leading to a branch sewer. So the direction of flow has to be towards where the branch sewer is on the sub-main road or some like that. So if you are laying the pipe perfectly horizontal in between the area of the sub-main and from where the buildings are there, then there are every chance that the sewer will get clogged because there is a lot of dense, heavy materials in your sewage. So if there is no proper gradient provided, then there is every chance that your material is going to get deposited. So the gradient part is very, very important in the case of laying of your sewer lines. So all that will be fixed before in the plan itself. So you have a certain sewer line, they will show what gradient this has to be. So when you say 1 in 500 or 1 in 1000, from the surface level of the ground, how much distance will be there where the invert of the sewer should be. So it is not the top of the sewer that is taken into consideration, the invert level of the sewer. It is the bottom portion of the sewer. So what is that level to be exactly, from which point you are starting, so that that gradient will be followed for that length of sewer line. So let us say we are talking about one 10 meter or 20 meter length of pipeline, or say 100 meter length of pipeline. So for this 100 meter length of pipeline, it has to be laid at a gradient of 1 in 500. So from the surface, the upper end of the pipeline should be at what level? The invert at the upper end should be at what level? The invert at the end of 200 meters should be at what level? So the gradient is decided. So every 10 meters or 20 meters, depending on the ground surface, however it is, they would know the exact location where the gradient or the level of the invert should be. So to help set that gradient properly, we have these cross rails which are called as site rails put across the trench that we are digging. So suppose we have a trench that we are digging, say 1 meter width. On either side of the 1 meter, we will have 2 vertical supports, and the site rail will be placed there. So this site rail, you will be such that the site rail can be moved up and down depending on what is the exact level from the surface that you require. And the boning rod will be put into the trench where you are laying the sewer, and the vertical part of the boning rod will be brought up to the exact location where your site rail should be fitted, so that you get the depth at that portion of the pipeline. So the site rails are set in such a way that the line sited along the top edge of the rail represents the true fall of the sewer. That means the exact level where the bottom of the sewer should be. This gradient is shifted below the ground by means of a traveler. Traveler is nothing but a boning rod. Boning rod is, it has got a shoe at the one end and a vertical piece at the attached to it. So the exact level can be measured. Like if you have a scale on that vertical portion, you will be able to tell from the ground, this is the depth of the invert. Site rails are horizontal cross rails placed on uprights, or what I was telling you, vertical pieces. They are usually made up of a good straight piece of timber, and the length is to extend over the width of the trench. So you can imagine a trench where on either side you have 2 vertical pieces which are supports, and you have a site rail across the trench. The traveler or boning rod contains of a rod and a T-piece. The T-piece is the bottom. So a small T-piece which we call as a shoe, which can be inserted into the trench and it will touch the bottom of the invert of the sewer. And the vertical rod is the one that gives you or you can fix the depth of the trench. It is also important that the boning rod should be cut to the exact length required. Otherwise, the pipes may not be laid correctly to the required gradient. This is the size that is normally used for a boning rod. Now, since the work of laying pipes is generally started from the lower end. So in the case of wastewater, they start from the lower end and proceed upwards. The site rails will therefore be required to be fixed at the lower end first, and then you will go up as the the pipeline continues. After fixing the first set of site rails at the lower end, and a second set of site rails is similarly set at some distance on the upstream. So the same height, after you decide the gradient, the particular height at which you want that the site rail will be fixed. Knowing the reduced level, that is the RL of the invert of the sewer at the lower end, and what is the desired gradient of the sewer line, the reduced level at every point can be calculated. This is the same way as the work that you did in your canal alignment. If you remember, when you design the canal for your extensive survey project, you know that you have to give a slope for the bottom of the canal. So if you know the invert level at the start, takeoff of the canal from the weir, from there the canal is supposed to be going downward. The flow has to be downward. So you decide what is the RL at every 5 or 10 meter intervals, and then you go searching for that RL so that you are able to allow the water from the weir to flow by gravity itself through the canal. So in a similar way, you will be, if you know the level at that point, for further across, you will be able to calculate the RLs and go. So the depth of the invert below the site rail should be the same to obtain the desired gradient. The top of the site rails will always be kept at the correct reduced level so that they want to check at all times. So this is the way in which they will keep laying the sewer lines. So from one end to the other end, they will continue repeatedly this. The calculated RLs will be there so that you know your bottom should be at this particular RL. Using the boning rod, the correct RL distance will be measured so that the trench bottom can be kept going according to that particular RL itself. Once the the RLs are all done and your bottom of your trench has been put to the gradient required, there will be a small bedding that is actually put so that the bed on which your pipeline is going to be resting is firm. That is also decided upon based on, again, whether it is a lateral, the diameter of the pipe, the type of soil where you are doing the work, the level of groundwater that is available there, etc. Based on all these factors, you will decide how much of bedding is to be provided so that your pipe rests firm and it doesn't gets squished or just penetrates into the soil because the soil is very soft. The pipelines will be done. All the jointing of the pipelines will be done. Previously, we used to study about type of joints that are being used, but now they are, that topic has been removed. But even for that jointing, we have studied about the spigot and socket joint or bell and socket joint, spigot joint that we have seen in water pipelines. Similar joints can be used if they are cast iron or such material. So every sewer length pipeline will have one end of it as plain and the other end will be cast as a wide flange. So the plain end of one pipe will be inserted into the wide end of the other, and the space in between the two will be tightened and made watertight. So there are now, you have large concrete pipes. So concrete pipes, the two ends of the concrete pipes will be brought together and with a rubber gasket or something in between. And there are concrete collars which will have a slighter, wider dimension than your inner pipes. And then the sealing material will be put in between so that the pipes can be jointed. Anyway, there are many methods by which joints can be applied to your lengths of pipeline as you continue doing your pipeline. That depends on the type of pipe material, and whichever joint is going to give you the most watertight joint for that material, that will be adopted. So by now the trench is ready, the bedding has been put, the pipes have been inserted into the trench, and the joints have all been done. So and everything will be done between manhole to manhole, most of the cases. So that the testing of, after everything is done, testing, if you are waiting, then it is very complicated. So they can test stage by stage. So it becomes easier to do that testing in that manner. So after you have finished laying the pipeline, it is necessary to test the sewer for water tightness before backfilling. Backfilling is you are either doing this on the side of the road or you are doing it in the center of the road. So the depth for any sewer line should be minimum 1 meter below the ground. Now, if we are talking about a road where there is very heavy traffic, then your depth should be even slightly more than that. So you cannot have too much of depth, nor can you have too less depth. Too much of depth, if you have like 2.5, 3 meters and all, if you go down, then the trench will be so narrow and your pipe has to be inserted from the top into the trench. And if there is any work that needs to be done, it becomes very difficult to operate. So that is one aspect. And the second aspect is, suppose you want to take out a pipeline later for repair purposes and all, then it becomes very difficult to take the pipe out. So the depth should be below 1 meters below the ground. Okay. But again, that will depend on the pipe material that you are using, the nature of soil there, and whether the road is very heavy traffic, because chances of crushing the pipe may be more in those cases. But on a general note, it should be greater than 1 meter. So we have put it the pipe, and then if you are trying to put the material back, once the material is put back, you will not be able to notice any type of leak or anything that is happening. So before putting it back, the pipeline will be tested. There are different types of testing that can be done. It can be tested for by putting water, and it can be you can look for seepage. So if you are trying to do it between one manhole to another manhole, say at every 100 meters or 200 meters, you have a manhole. The lower end manhole will be, the outlet of that manhole will be shut. So the sewer pipe runs continuously through these manholes. Manhole is like one component part in your sewer line, but it is not a pipe, it is a chamber. So if the outlet of that chamber is shut off and you pump water at little pressure from the other end of the through the other manhole, then water will pass through this pipeline that you have laid. And since the soil is fresh, any type of leak that happens can be easily observed. So the water test is performed for underground sewer pipes before backfilling is done. The test should be carried out by suitably plugging the lower end of the drain. Okay, suppose you are doing it from manhole to manhole, the outlet of the manhole at the bottom will be closed, and from the other side they will pump water. Plugging the lower end of the drain, filling the system with water. A knuckle band shall be temporarily joined at the top end, and a sufficient length of pipeline and sufficient length of vertical pipe is jointed so as to provide the head required. So if you are doing it directly on the pipeline, you need that. But if you are doing it through your manhole, you can directly flood the upper manhole so that water is passed. So if there is suddenly level lowered in your test pipe, then probably it could be because of two reasons. Initially the pipe joints may be absorbing water or even causing leakages at that point. So any leakage, if visible, the leakage is usually seen at the joints because those are the weakest parts. But sometimes what happens, the pipe itself may have been damaged in some way which was not observed earlier. Now you need to even test the pipe for straightness and obstruction. There is, other than water, sometimes they do test it for smoke also. Smoke test can also be done. Smoke test is observed for the obstructions, if there are any, like soil or something has been put inside. So you test for the straightness and obstruction. For the straightness, a mirror is placed in front of one end of the sewer and the image of the section is observed. If the sewer line is straight, the image of the sewer line will appear as a circular portion. If it is not a complete circle, then the straightness is a problem. Now, for sometimes you are testing for while you have put the pipe material or laid the pipe material, sometimes soil would have entered the pipe material at some point. Sometimes while jointing, some mistake has happened and the joint, this is especially when the pipe sizes are small, the joints would get obstructed in some way. So for testing this, a steel wire can be inserted and they can pull it down, and if the wire is coming clear and they rotate and see, they find does not have a problem. Another thing they can do is they pump smoke at one end, then smoke should come out from the other end. These are methods, simple methods that can be used to see for obstruction or straightness within the pipeline. Now we come to the next topic, ventilation. So first, why is ventilation needed? So when we talk about a building, we say ventilation, doors, windows, etc. And if we are keeping our doors and windows closed all the time, we are not getting any ventilation, and the air inside your building becomes stale. Whatever respiration heat or respiration gases are coming out, all that remains within the chamber or within the building itself. But the moment you open a window or a door, there is the movement and this hot air can go out. So that is the actual meaning of the term ventilation. You allow the stale air or gas to go out. Now, what stale gas are we talking about? In sewer lines, because there is waste water flowing, a lot of organics are present. And these organics are continuously getting subjected to degradation by microbes that are present in the water. And you have so many gases of degradation that are getting generated or built up. So there is methane, there is hydrogen sulfide, there will be carbon dioxide, there will be some amounts of hydrogen gas, nitrogen, etc. Now you would have heard cases where sewer lines have blown up, okay, because there was no ventilation. You would have heard where flaring, no, because the gases have built up so much and somebody has tried to enter just for checking through manholes. If by mistake they have used a lantern or something, putting it down, sudden flare up will happen because these gases have built up and these gases have calorific value. So if subjected to small heat, temperature, etc., and they get ignited, they will burn. So many such accidents do happen, and because of that, you need ventilation in your sewer system. Now, in your buildings or houses itself, you know that from the closets and all, we have a long pipe, a vent pipe that comes with a cowl at the top, which allows for fresh air to be within your system or chamber, chamber or toilet, whatever it is. So if that air is not removed, then those foul gases plus the ignitable gases will remain there. So the process for ventilation is to allow the fresh air to come into the system and the foul air to leave the system. So sewage flowing in a sewer line has got a lot of organic and inorganic matter present in it. Some of these matters decompose and produce gas. These gases are foul smelling. For example, hydrogen sulfide, etc., will have a very eggy smell, corrosive and explosive. And these accidents do commonly happen also. There are many manual laborers who have burnt or got themselves burnt by entering into such sewer lines while cleaning and maintenance. Okay, that's why now they have told that no human should be allowed to enter without any protective gear into such sewer lines, etc. If these gases are not disposed of properly, they may create a number of difficulties. They may cause airlocks in the sewer. This is other than the gas buildup and things like that. Will air block we have experienced in our pipelines. You can hear that gurgling sound. The water is not able to move because an airlock has been created. Similarly, your wastewater also flow will be obstructed by when large quantities of air blocks the system. Causes airlocks in the sewers and affects the flow of sewage. This may prove to be dangerous for the maintenance squad working in sewers. They may also cause explosions and put the sewer line out of commission. For the disposal of gases, ventilation of sewer line is a must. There are various ways by which ventilation can be provided. Laying the sewer line at a proper gradient. Now, you will think, why laying it is a proper gradient? Because, see, when liquid is flowing, it is the gas that gets collected on top of the liquid. So you have a place where there is a sudden depression and then your pipeline is going up. So those are places where there gives a chance for the air buildup to happen. So if your pipeline is being laid with a correct gradient along through the link, chances of such places where airlocks can come are minimized. That's the reason for having it being laid at a proper gradient. Running the sewer at half full to 2/3 depth. See, sewer lines are never designed to run 100% full because that can cause a lot of problems. And you need some space where the accumulated gas can be collected. So if you are designing, so this comes in the design factor itself. So remember when we talked about when we are designing for separate or combined system, we always take a peak factor so that extra liquid or wastewater coming is also accommodated. So when we are accommodating that and designing, most of the time our sewers will not be flowing at a much higher capacity to half or 2/3 full. So if we are getting that ideal condition of flow, chances of these blocks happening because of airlocks can be reduced. Providing manhole with grating. So like I was trying to convey to you earlier, manholes are a topic that comes after this portion. Say 200-meter length of pipeline. One end you have one manhole, another end you have the other manhole. Manhole is a part of the sewerage system, but your sewer line will enter one manhole and the manhole chamber will be there and the next sewer line will take off from the other end of the manhole. So the manhole is like a chamber. The manhole always will have a cover. Okay, many times you would have seen the cover of manholes sticking out of the road in many places, though they are supposed to be flat. And if we are able to provide a grating is like the cover that is put in our flow traps, etc. inside the house. Under the wash basin or sink, you will find a small grating which is covering the trap. Okay, so it is and allows for the gases that get accumulated there to leave. So that's a very ideal condition. Proper drainage, house drainage, that starts from your building itself. So from your building, you have your individual house sewer connected to the one on the main road or on your road, lateral road. That will be called as the lateral sewer line. So in your house, the small pipe that is carrying all the wastewater will be connected to the manhole on the lateral. So the laterals can have manholes. The branch sewers will have manholes. The main sewers will have manholes. And the size of the manholes will again be dependent upon where that manhole is actually getting constructed. So if you are able to provide a proper connection, you would have read articles in newspapers where people have told that during certain rainy conditions or because of improper laying of drainage system, sometimes the water in their closets rise and comes back into the closet and they have a foul smelling, overflow happening. These are all because of the improper laying of the drainage system. You have various appurtenances in the drainage system to prevent the backflow from happening into your building, because otherwise you can imagine the wastewater from the main sewer outside is going to come and flow into your sewer pipe, and obviously it will start rising in your closets. So such conditions do happen in certain cases. Sometimes it is during heavy rains where, you know, unexpected water enters into the manhole and it's not able to take up. Sometimes it is because of improper laying of the drainage pipe. And then providing ventilation for shafts. Sometimes there will be ventilation shafts itself installed along the pipeline. I've got a figure at the bottom of this, which is the way in which the ventilation can be taken care of. You can see this part of like a structure like this, probably in your individual houses also you see this at that for the house we call that as a cowl. Okay, nowadays you get a PVC top for that. You can put that and it will have holes or vents at the top. It will be going. So look at this. This is the sewer connection, and they attach a vertical column to that. This gives the shaft so that any gas buildup that is happening in the pipeline can be removed. So a quick rewind at what we saw today. We talked about laying of the sewer line. We talked about testing of the sewer line, and we talked about ventilation in the sewer line. So laying is always started from the lower end to the upper end. You need to have the plan. Suppose we are talking about laying the sewer line for a layout. You need to have the exact levels of all, like we did it. So this is the exact thing we were trying to do at mail coating. You have taken through individual crossroads everywhere the levels. Why? Because you need to know what is the exact levels there. You know the direction in which the liquid is going to be flowing depending on the terrain. So you try to fix the treatment plant at a lower level so that all the wastewater collected laterals to branch, branch to main, and from mains into the treatment plant. So that flow will happen without any extra pumping required. That will be the ideal system. So you need to have the entire layout before you can start laying. And usually manhole to manhole laying is done so that that stretch you can test stretch by stretch. Testing has to be done for water tightness. Testing has to be done for straightness of pipe. Testing has to be done for obstructions in pipeline. So for all these, you will do testing. Then we come to ventilation. Ventilation is allowing, in this case, the foul built up gases, air of decomposition or airlock, which is building up in the system, to be vented out from the system, because else it will cause blockage in the system. Because of airlock, it will cause buildup of high volumes of explosive gases like methane or odorful gases like hydrogen sulfide, etc. And it can cause dangers to the life of the maintenance crew who are going to be servicing these pipelines. Hence, this requires to be removed. You can get the ventilation done properly by laying the pipeline properly, by providing manhole with vents, by providing ventilation shafts, etc., so that the release of these gases can be done properly. So that is with respect to laying, testing, ventilation. And commonly all these things are grouped together. Okay, so that portion is over with respect to ventilation of sewers. Now, coming to what we talk about as low cost treatment. Actually, this was supposed to be in a treatment portion of your syllabus, but this low cost treatment is not included in any part of your syllabus otherwise, and in the CBCS scheme, they have merged it with this portion. And here we talk about only two types of low cost treatment, of which One, during our open course, few of you would have at least attended that. We talked about septic tanks. And the second one is an oxidation pond. So in your extensive survey, we had decided that the wastewater from a Melkote town is not so excessive in volume, and since they do not have any industrial discharge and things like that, we could treat it in a low cost manner as in an oxidation pond. So first thing for you to remember is, what is low cost waste treatment? All of you at one point of time would have gone to our STP, which is located in the college campus. That is a sewage treatment plant, a very small one for our campus. And there you will see running equipment or machinery which is trying to pump air into the system so that the system is kept aerated. Now, if I talk about aeration, I need a blower. A blower works on electricity, and therefore I am spending money for getting my system aerated. But when we talk about a low cost system, it should be in such a way that once you have constructed and built the system, it is able to operate for long duration of time without any other extra intervention. No supervision required, nothing required. So oxidation pond, many of you may not have seen, but I'm sure that whether you have attended the open course or not, many of you will be familiar with what we call by the term septic tank. Some of us may be having it at home. So these are the two simplest low cost treatment or waste treatment units that can be provided. So now let us look at oxidation pond. These ponds can also be called as stabilization ponds. Sometimes they are called as lagoons. You have heard the term lagoon, right? A lagoon is when usually seen near the ocean, where a part of the ocean water somehow gets separated by a strip of land and you have a pool. Okay, that pool we used to call it as a lagoon. So here it can be an artificially created pond, or it can be a natural pond that they are using it for treating wastewater. Okay, so such designed systems are called as oxidation ponds. So oxidation ponds can be called as lagoons or stabilization ponds because all the waste water, when we are allowing it to get collected there, we are not giving any other treatment, so there are solids. Now when we use the word stabilization or stabilized, it means that the organics and other material which is present is getting converted into a stabilized form. It gets degraded by the microbes, and the contaminating capacity or polluting capacity of the solids are reduced, whereby all the solids get converted into stabilized. Like we say, after that the sludge is not going to do any harm. Okay, it is in a stabilized manner. So hence the word stabilized ponds. These ponds are designed as shallow. Why shallow? When you have very great depths, chances for development of anaerobic condition is more. If you have a shallow pond, then sunlight will penetrate to the pond and there is an action of disinfection which will help in removing some amount of polluting capacity of the wastewater. Plus at the same time there are algae and microplankton, phytoplankton which are growing in the water, even the microbes which can utilize the air that is getting exchanged between, or oxygen that is getting exchanged between the liquid and gaseous medium, and the presence of sunlight which is able to actively use up the organic content which is present in your wastewater and degrade them. So it's better to keep the pond at a shallow level, 1 to 2 meter depth. So you have shallow ponds designed to treat wastewater through the interaction of sunlight, bacteria, algae, or you can talk about phytoplankton also in this case. Algae grow using the energy from sun, carbon dioxide, inorganic materials that are present in your water are released by the bacteria into water. All this is the common thing that happens within the pond. During the process of photosynthesis, the algae will release oxygen. This can be used up by the aerobic organisms, and sometimes when they are having a slightly deeper pond, they will have to use mechanical aerators. But when it is a low-cost treatment plant, this can be avoided. Now, I'll tell you where they use this. There are many industries where after giving a basic level of treatment, they will use the stabilization point. So now industries, they want their work to be over fast so that the pond can be reused for the next liquid set. The water will evaporate and they will reuse. So at that time, they will provide mechanical aerators so that the rate of decomposition happens at a faster rate. And you see, thereby reducing the size of the pond. So when they are having it within their campus, okay, if they can have a smaller sized pond, if they are ready to spend money on the mechanized aerators. Sludge deposits in the pond will be removed by dredging. So whether it is your pit, whether it's your septic tank, sludge will get deposited at the bottom. You will have to remove it at a later stage. Algae remaining in the pond can be removed later by a combination of chemical process or by settling it. So you can add potassium permanganate, which is a very good, algicide. So all those can be removed. Advantages: suitable for hot climate, especially in climates like India, and your UV radiation from your sun will also have some disinfecting action. So it's very good. Best suited for small cities and towns, but land has to be cheap because you're losing land area here. Capital cost is only 20 to 30%. Hence, it is called as low cost. Maintenance cost is very less. Dredging, removing, cleaning after so many years, whatever material is getting deposited. That is the only thing. No skilled supervision. Flexible and will get upset due to sudden fluctuations. That is, today you are sending in some water of normal BOD, say 1000 milligram. But tomorrow, some industrial effluent is coming and you have BOD ranging up to 4000. And that also you are sending there without treatment. Then there is a problem. But otherwise, it is quite flexible. This is the original shape. So this is a plant set up in an university campus where they have some amount of wastewater treatment with some small units that they have. All the wastewater is put into these ponds. I can show you the line diagram. See, aerobic and anaerobic you can have. Anaerobic will be when you have greater depths. So always try to keep the depth smaller. So this is the same system that we have been studying from school days. You have water, oxygen, the plants will get your carbon dioxide, the algae, whatever is there, will give out oxygen, your bacteria will use that oxygen. Whatever wastewater is coming, there will be a lot of organics present in that, will get eaten up by the bacteria, used by the plants, and then you will have whatever is remaining there at the bottom. This is the sun. So I think we will continue with the septic tank in the next class because our time is going. So a quick quiz on what was happening today. I want the person whom I am talking to respond.